Okay, I promised you a video explaining Argc, Argv. I seem to have lost my old video, so I'm recreating it for you. Take a look here in the uh, definition of main, and it says int main. Now remember, an int is 32 bits. Int argc, so argc is 32-bit integer. Char star star argv. So you can read that in the following way, that argv is a pointer to pointers to char. Okay, here's another way of doing interpreting exactly the same way. Char star argv array. So argv is an array of pointers to char. Now remember, an array itself is a pointer. So that's how you get back to pointer to pointer. Okay? So the value of argc is the number of non-null entries in the array argv. So if my command line were a.out abc, the number of non-null entries is 4, and the indices that are valid is 0 for a.out, and 1 for A, 2 for B, and 3 for C. But there's a 5th entry in the array, and that is a null terminator that you see here. Okay? So the idea is that argv is a pointer to an array of pointers to char. Okay, so let's take a look at each of the strings of char. You'll notice that every one of those ends in a null byte, a null terminator, a 0, a character, a byte whose value is 0. Just compare that here, that this is 8 bytes because it is in the place of a pointer, 8 bytes of 0. Okay? So let's take a look at how this translates into assembly language. The argument passing or parameter passing standard in Linux says that the first argument appears in the first register. The second argument appears in the second register. So you see, I have written W0, the first register, and X1, the second register. The difference between W and X is, remember I said that int argc, int is a 32-bit value. So W0 occupies the same hardware on the CPU as X0, but X0 is considered, the X's are considered 64-bit, the W's are considered 32-bit, and then there's a way of dicing it down even smaller than that to 16-bit and 8-bit, but that doesn't enter into it here. So W0 is the first register, and it's a W because the value that is being held in it is a 32-bit integer. The next argument is a pointer. It's a 64-bit machine, so the X register is used because X registers are 64 bits in length. So W0 in this case will contain 4. And again, that is the number of non-null entries in the array. So here's 1 and 2 and 3 and 4. Keep in mind, there is always a 5th entry in the array, but it is a null. It's zeros. Keep in mind that each of these are 8 bytes wide, 64 bits. So if you were to look at the contents and look at the addresses, and always remember that a pointer is synonym for address of, okay? So if you were to look at these values, and I just made these up, so there's no rhyme or reason to these numbers. The only requirement that I had is that the numbers refer to different locations, and I've done that. So if argv or x1 contain the address of 1000 hex, that means at memory location 1000, there is the beginning of the array. So that 1000 hex points to the first byte of the array. Then if we examine that memory location 8 bytes at a time, we can continue marching through it from argv sub 0 to argv sub 1, etc., until we find a null terminator here, and we know we have come to the end of the array. So if x1 comes in with a value of 1000 hex, then we can go into memory and find at location 1000 hex, the beginning of an array. Its first 8 bytes contain together 1200 hex. So if we were to go into memory at location 1200 hex, we would find the period in dot slash a dot out. We would find the first dot. And we can then march along the C string until we find the 0. And that says we're at the end of the C string. If we were to advance relative to x1, if we were to advance by 8 bytes, we would then end up here. Its contents is 800. If we were to examine memory at location 800, we would find A followed by a 0, and so on. So this is how Argc, which is minor, but Argv is laid out, and how you follow the pointer to char, and then once you get to the char, you march forward until you hit a 0, and that constitutes the entirety of the C string. Okay? So in the program that, or the don't panic that I showed you, x1 is immediately saved into another register. And the reason for that is x0 through x7 are scratch registers. You can't count on them being preserved if you make a function call. So we are going to make a function call, namely puts, which does the printing. We're going to make a function call, so we can't rely on x1 being there for us after the function call to puts. So we're going to put x1 in that code. I believe I put it into x21. So x21 is pointing to the beginning of that array. So you need, let's put in the dot slash a dot out. What you have in x21 is this value. What we want is this value so that we can go fetch the characters in the string. So if you were to use x21, put the brackets around it, that says dereference x21. Use the value in x21 as an address, go out to memory at that address, and fetch its contents. And I'm going to put in an X register here. Let's say X1, and that is going to be an LDR. So LDR says load from a register, go to out to memory at the location specified by this register. That's what the brackets do. That is the dereferencing of the pointer, where the register in between the brackets is considered to be the pointer. So dereference it and put its contents into X1. Now, what is that contents? That contents is 1200. So that means at this point that X1 has 1200 hex. Okay, so that means we have the value of this memory location, which is 1200 hex. But that's not where we need to end. Where we need to end is the actual characters itself, which would be to load. We could do, if I wanted to fetch the first character, and I'm going off the script here. So sorry, I got myself wound up and I'm going in a different direction now. If I wanted to get the first character, namely the dot, what is the address of dot slash a dot out? The address of dot. Well, its address is 1200, and the 1200 is in X1. So to get a byte, you would LDRB for byte, and you have to use a W register. So X is only for 64-bit things, W is for everything else. And I'll put that in W0, doesn't matter. W0, dereferencing X1. So now W0 has a dot in it. Now, if you wanted to get to the slash, dot slash, you would simply increment X1, right? If the very next thing you wanted was to get to the slash, well, you can do that in one instruction, in the very same instruction. If we want to advance by 1 byte, then comma 1. That is a post increment. That is the same thing as saying a pointer plus plus. Okay, all of this here is embodied in that. So if we wanted to advance by 1, but in the don't panic code, we wanted to advance by 8. So that would have been here a post increment of 8. And that would advance the pointer from here. X21 started here. After the increment by 8, it would be pointing here. Okay, so hopefully that explains the background between Argc and Argv, and also lifts the hood a little bit, lifts the curtain, on some of the assembly language that goes into accessing Argv and Argc. Very good.